So in this video I'm going to talk briefly about the formula to find the angle between two lines. A couple of things just in the background. We want to find the slope of a line, and we just have one line, a single line that slopes in some way like that. Every line has, a run and a rise that can be compared in a ratio. And if I just call that angle A, you can see there the tan of that angle is equal to the rise over the run. And that's precisely our definition of slope. So we can find the slope of a line by finding the tan of the angle it makes with a horizontal. Okay. Also, from junior cert, we had something called the exterior angles theorem, which said, in a triangle, that the exterior angle here, let's call it A, is equal to the sum of the two interior opposite angles. If we call that B and that C, we could very easily show that A is equal to B plus C. Okay, A added to this angle is 180. These two added to this angle have to be 180 also. So A has to be the same as these two. Okay, and we also have an identity, which we would have looked at in our list of identities. I won't go through the proof of this, but I will just write it down. So remember, tan of A minus B, we have an identity for that. That's the tan of A minus the tan of B all over 1 plus tan of A multiplied by tan of B. Okay, so that's kind of a bit of background. Those three kind of pieces of information are important to understanding where this formula comes from. Okay, so when we have two lines intersecting, it doesn't really matter how they intersect. If I take a horizontal line down here, and I call this angle, let's just call it angle A, and I'm going to call this angle B over here, and I'm going to call this angle up here C. So if I want to think about this angle C, which is the angle between the lines, one thing from the exterior angles theorem, this angle B has to be equal to angles A and C. So it can be shown that the angle C must equal to, well, B minus A. If B is equal to A plus C, well then C is equal to B minus A. That's fairly straightforward. So I can say the tan of that angle C will be the tan of the angle B minus the angle A. Okay, and we have an identity for that. That would be tan of B minus tan of A all over 1 plus tan B times tan A. Okay, and if this first line, we'll call this L1 and we'll call this L2. It doesn't really matter how I name them, but tan of B will give me the slope of L2. Tan of A will give me the slope of L1. And so tan of B will be the slope of the second line. Tan of A will be the slope of the first line, all over 1 plus M2 times M1. Okay, and that's a formula for finding the angle between two lines. Okay, in practice, we generally try to find the acute angle between two lines. So what we do quite often is we'll say we have to make this positive because the tan of any acute angle is positive. So in practice, generally, we'll kind of think about that as being an absolute value. Okay, so let me look at one example using this formula. And this formula is in your formula and tables booklets in your coordinate geometry page. Make sure you can find it. That's really your job. An exam will be to find the formula and apply it. So here's a fairly straightforward question. It says, find the angles between the lines L1 and L2. And it tells me L1 has the equation y equals 2x plus 5. That's nice. That's in slope-intercept form. So the slope of that first line is 2. I can read that straight off. The second line is kind of in a standard form here. So I'm going to just change it to slope-intercept form. So if 3x plus y equals 7, then y is equal to negative 3x plus 7. So you can see the slope of that second line is going to be negative 3. Okay, I want to find the angle In fact, it says find the angles between the two lines. There's always two angles. They're either one acute and one obtuse, or else they'll both be right angles, okay? If there are right angles, you would probably see it already. This slope would be the negative reciprocal of this one, okay? So if there were right angles between them, well, then the slopes would be negative reciprocals. I can see 2 is not the negative reciprocal of negative 3, so it's going to be one acute angle, one obtuse angle. I'm going to find them both, okay? And I'm going to use my formula. I'm going to say tan of the angle between them, tan of whatever we call it, let's call it theta, is going to be equal to, and we have a formula here, okay, from before. We're going to use my absolute value brackets here, m1 minus m2 all over 1 plus m1 m2. You know, if you wanted to get a rough picture of what this is a slope of 2. You know, every time we run, we rise 2, something like that. This will have a slope of negative 3. Every time we run 1, rise negative 3, a bit steeper, something like that. We're going to find the acute angle between them first, and then from that, once we know that angle, we can just subtract that from 180 to find the obtuse angle. Okay, so really straightforward, just substituting things into my formula here, and we're going to have the absolute value of 2, subtract m2 is negative 3, all over 1 plus m1 times m2, well, that's 2 times negative 3. So we've got 2 plus 5, or sorry, 2 plus 3, I should say, which will give me 5 on the top. And on the bottom, we have 1 subtract 6. Okay, so we get tan of theta is equal to 5 over negative 5, the absolute value of 5 over negative 5, well, that's the absolute value of negative 1. Okay, so tan of theta is equal to 1. So tan of theta is equal to 1. That's one of my special angles. I should be able to identify that straight away. If tan of theta is equal to 1, well, then theta must be equal to 45 degrees. Okay, so tan of theta, I'm going to take the absolute value just to give me a positive thing. That guarantees me I get the acute angle. So we get theta is equal to 45 degrees. So the acute angle between these two lines is 45 degrees. The obtuse angle, so the acute angle is 45 degrees. The obtuse angle is equal to 180 minus that. That'll be 135 degrees. So that angle in there would be 135. Okay, this one in here will be 45. So whenever two lines meet, there's two things that could happen. We're either going to have an acute and an obtuse angles, or else we're going to have a pair of right angles. That's it. Nothing else can happen. If it was a pair of right angles, you would see from the slopes, remember we said perpendicular lines have slopes that are negative reciprocals of each other. So I can find the acute angle, I can find the obtuse angle. If I'm finding the acute angle, I use my formula. If I'm finding the obtuse angle, I use my formula to find the acute angle and then just subtract the result from 180 degrees. Okay? And that's how we find the angles between two lines. All right? So practice, practice.